Hey folks, Mr. Lackey here. Welcome back to some online school stuff. Been a while since I've seen your faces or you've seen mine. Secretly this month I've been growing a very patchy, I guess you could call it a beard. Yeah, that's what's new with me. Hope you guys had a great Thanksgiving week, and I hope you're ready for just the last couple weeks here of online class. We're going to start this lesson today by looking at the actual periodic table. Depending on which cohort you're in, you might have had a chance to actually color one in and make a nice color-coded one. If you're in cohort B, you didn't have a chance to do that yet. So we're going to just look at the periodic table here real quick, and we're going to talk briefly about these colors. Just notice I'm on ptable.com because that's the website we often recommend that you guys go to. What we want to point out here is that these colors actually mean something, right? So over here all the way on the left, we've got a whole column that's orange, and you'll notice that there's a key right here in the middle. That tells me that this is an alkali metal, and that's where the metals are on the table. A nice little thing about the key too up here on this website, if I click on metals, it'll show me all the different metals on the table. If I want to know just where are these things called the lanthanoids, boom, they're down here at the bottom. If I want to know where the transition metals are, I can go over there. It shows me they're pretty much all those ones in the middle. The alkaline earth metals are right over here in yellow. And again, if I move my cursor away from there, I can see the color of everything on the table. There's some things that are somewhere between a metal and a non-metal here called the metalloids. And then you'll notice the non-metals are over here. There's a couple different groups. There's the noble gases and then the reactive non-metals. So those are the things that we're looking at on the table. Because I wasn't able to give many of you a copy of the periodic table before you went home for distance learning, then I'm going to definitely say a lot of the problems that you need to use throughout the rest of this unit, you're going to use ptable.com to help you out with that. So let's actually go ahead and let's talk through some of the basic terms you need as we talk about the periodic table. So I'm going to flip over to some notes here. So let's just talk about some of the basic vocab that you want. So first of all, a column on the periodic table. So a column, remember, something that goes up and down. So over here on the left, I have two columns that I've circled in purple. In the middle in orange, there's a bunch of shorter columns. And then on the right, there's some more taller columns again. We call those groups or families. So if I said, oh, look at this group or look at this family, that means I'm talking about a column that goes up and down on the table. These ones that I've circled in purple, they're actually called the A columns versus the ones that are in short in orange here are called the B columns. I actually want to jump back to ptable.com because I want to mention something here. So you'll notice then that means that like column 1 and 2, those are A columns. So that's family 1 and family 2. All of these through here, these actually then, this is 3B, 4B, 5B, 6B. All of these short ones are B columns. It gets a little tricky here because of the naming. I kind of wish this website showed it a little bit differently, but column 13, so that's actually known as column 3A because these columns, the tall columns, are called A. So like this is 1A, this is 2A, and then the third A column is over here. So these ones in the teens, you kind of have to just remember that like 14 is also 4A. And 18 is also 8A because it's the 8th A column. Because in between 2 and 13, there's 10 of these shorter B columns. It's going to be a pretty key distinction when we're talking about some of the things later on in our notes here. Okay, so then looking back here, when we look left to right across the periodic table, these are horizontal rows, and those are called periods on the periodic table. So, for example, up here in top, on top, I've circled or I've highlighted one of the periods here. Notice even if there's gaps in between, that's still one continuous period. So this is actually considered the second period on the periodic table. Up above that, the first period just has 2 elements in it. So I've got one element here and one all the way over there. That's the whole first row. That's period number 1. Down here, I've got period number 2. It goes 2 elements, a big gap, and then the elements pick back up on the right side of the table. If I were to count all the way down to this row down here, so it's 1, 2, 3, 4, 5, the 6th period, notice that's a full period all the way across. That row continues all the way across the table. All right, so some of the terms we've had so far, remember up and down, we call those columns they're called groups or families, and then left and right, we're talking about periods on the periodic table. So we also then break it down further into these categories based on their chemical and physical properties. So that's what I was showing you a moment ago on ptable.com. That's your things like your alkali metals, your transition metals. When you look at a periodic table and you see all those colors going through it, those colors are the categories that we're talking about. Remember, they're labeled on yours if you happen to have a hard copy of it, if you were in school before we got sent home, but if not, you can always use that website. So what we're going to do is we're going to look for some themes in the family, and I'm actually using some of the projects that you all turned in a couple weeks ago. So family themes, so for example, for family 2A. So I picked 3 elements, so beryllium, magnesium, and calcium. So if I go side by side with the table, notice over here on the left side, calcium, it has, this Bohr model is filled out correctly. So it goes 2, 8, 8, 2. The outer ring has 2 electrons on it, right? Magnesium, so that's 2, 8, 2. Beryllium just goes 2 and then 2 more. So notice though, these are all things in family 2A. And in family 2A, and what we mean by that, if we go over to the periodic table, here's our families, family 2A. So those are the first 3 elements in 2A, beryllium, magnesium, calcium, right? So if I'm looking at those 3, notice they all have something that unites them. And that thing that unites them also is something that comes from the fact that they're in family 2A. Maybe you figured it out already. All right, let me go to the next slide, see if this helps you. Let's look at some family themes. Now this is for families 3A, 4A, and 6A. Now remember, you got to recall that trick. So aluminum, if I say family 3A, you might be like, oh, family 3. Remember, that's not actually where it is. It's 3A, which is all the way over here. It's like 13, right? So 3A, there's aluminum in family 3A. Notice it's in 3A, and check out its Lewis dot structure. Remember, that tells you about how many valence electrons it has. Okay, SN, that's tin. That's from family 4A. So here's 14 or 4A. I go down. Here's 10. Oh, okay. 10's in 4A. 4 valence electrons. All right, here's sulfur. Sulfur is over here in 16 or 6A. Sulfur is right in there. And notice how many valence electrons it has. Okay, so we should be seeing a pattern, right? All right, let's look for another pattern here that goes with what period each element comes from. So let's go ahead again and let's look closer at some of these. So now we're looking at things all from the same period. So these 3 elements are all from period 3. I believe we're looking at sodium on the left, magnesium in the middle, and chlorine on the right. I'll bring the table back up in a second, but so I go 281, 282, 287. Okay, not really a clear pattern with the valence electrons. This one has 1, this one has 2, this one has 7, right? But they do all have something in common if we're checking out how many rings they have, right? So this one gets to the first, second, third ring, first, second, third ring, first, second, third ring. Okay, well, let's take a look here then. Let's go ahead and do our half screen again. I think that will help us out. So let's look at things from different periods. So here's beryllium. We looked at that a minute ago. So beryllium was in family 2A, but also if I look to the left, it's in period 2. So in period 2, here's beryllium. Okay, it's got 2 of something. All right, this next one is a really large atom. I'm actually not even sure what atom it is. Well, actually, I can do the math really quick. I think it's gallium. Gallium. Okay, so here's gallium, Ga. It's in period 4. So I count down 1, 2, 3, 4. There it is. Now it's in period 4. Notice it only has 3 valence electrons. That makes sense because it's in family 3A, 3 valence electrons. But if I look over here in period 4, it's got 4 of something else. Okay, here's another one over here. This is number 50. This is tin. Okay, so it's a little bit cut off, so I can't quite see the number of valence electrons, but I can say 10. I look over here, it's in period 5. It should have 5 of something if I'm looking at that drawing. Okay, so if you've been following along on that digital handout, you might be able to write on your own what themes you've noticed. So atoms all in the same family should have something in common. Atoms all in the same period should have something in common. Let's go ahead real quick. Let's kind of fill this in. There's some notes right below this section on the handout. So what pattern or trend do you notice? So for every family or group, it matches the number of valence electrons. And remember, that's for the A family. So if you're from family 7A, you have 7 valence electrons. If you're from family 1A, you have 1 valence electron. Every period that you're in, that tells you the number of electron shells. So if I'm in period 2, I have 2 electron shells. If I'm in period 5, I have 5 electron shells, right? Each one of those is a match. So for example, actually there were 2 questions I just skipped over. Let's go to the last slide here. So it says make a prediction. Over here, how many valence electrons do you think carbon has and why? If you go ahead, if you haven't done it yet, pull up ptable.com, find where carbon is, and see if you can, based on the notes we just took a second ago, figure out how many valence electrons it should have. Okay, now you've done that, let's go ahead and say, all right, now let's look at some elements in the different periods. So let's go to the same element, right? We can figure out what period carbon is in, and we can say, all right, well, how many electron shells should it have based on this? All right, I'll give you a minute. Take a look at ptable.com, see if you've got an answer for it. Okay, if you want to go ahead and confirm those answers, right, let's just go back to the periodic table. Let's find carbon. Here's carbon, right? Carbon is over here in 14, which is also known as 4A, and it should have 4 valence electrons. In fact, I want to point out over here on the left, it gives you the electrons in the order they should appear. So there's 2 here, 4 here, right? It's also in period 2. Period 2 means it should have 2 rings. That's why I have 2 different numbers. I've got 2 electrons in the first ring, 4 electrons in the second ring. I can do this for literally any element as long as it's from one of the tall columns. So let's say I go ahead to selenium. Before I even click on it to confirm, right? Selenium right here, it's in period 4, so it should have 4 rings, and it's in family 6A, so the last ring should have 6 electrons. Let's click on it. When I click on it, look over here at the numbers. I have 1, 2, 3, 4 rings. It goes 2, 8, 18, 6. And I have 6 valence electrons in the final ring, right? So this is a really great sheet to tell you right away how many valence electrons something has and how many electron shells it fills out without having to fill in the whole thing on your own. I do really want to point out this trick only works for the tall columns. If you go down to this middle section, remember these are called the transition metals, those ones that I've just brought up in pink there, this trick does not work. In fact, let's click on one of them. Let's go to chromium, okay? So I might say, oh, 4 electron shells, 6 valence electrons. If I click on it, it does have 4 electron shells, but it does not have 6 valence electrons. If you look through those electron patterns, they don't make sense based on the rules we've learned. 2, 8, 13, 1, those don't follow any of the rules that we know. That's because these ones here in the middle, these transition metals, they don't follow those Bohr model rules. Okay, so I'm not going to give you one like that on a test or a quiz. I will give you stuff like these other ones, like I might say, how many electron shells should xenon have? I can just look at it and say, boop, it's got 5. It should have 8 valence electrons. I can click it to confirm. 1, 2, 3, 4, 5, 8 valence electrons, right? There are questions on the back of the handout that go with this activity. You should be able pretty easily to pull up ptable.com and answer those questions based on the activities that we just did here together. And then there's like an open note quiz with a few of those questions and maybe a few other ones, just making sure that you understand this concept. All right. Thanks for following along, guys, and I hope you have a good week. Bye. Hey, here's a video of a video playing inside of another video. All right, let's go ahead and see if it works.